Hi everyone. Today's video is about the families on the periodic table, and it is brought to you by Help Young Minds, and I'm your host Arju Neupane. So let's get started. Like I mentioned, we're going to talk about some of the families on the periodic table, and we'll start off by describing what a family is. If you look at the periodic table, you can group elements into rows or columns. The rows are called periods. So this would be period 1, where it includes hydrogen and helium. This would be period 2 and includes both of these as well as all of these. And this would be period 3 and so on. Today we're not really going to be focusing on the periods. Instead we're going to look at the columns, which are also called groups. So this would be column 1, this would be column 2, and so on. We're going to be talking about 4 groups, and they're given common names and are referred to as families. So group 1 would be alkali metal family, group 2 would be the alkaline earth metal family, group 17 would be the halogen family, and group 18 would be the noble gas family. Another thing I want to mention is how the groups are numbered can be different depending on the periodic table that you look at. So on this periodic table, they're numbered from 1 to 18. And this is actually the preferred way of numbering by IUPAC, which is the International Union of Applied and Pure Chemistry, but there can be other ways. However, if we look at this periodic table, you can see that there's other ways of numbering the groups. So it does show the 1 to 18 numbering, but it also shows 2 other numberings, which are older numbering systems that have fallen out of favor. So they use the letters A and B, and they also use Roman numerals, and they're not really used anymore because it kind of gets confusing since, first of all, you're using A's and B's, and also the numbering doesn't always increase. So what I mean by it doesn't always increase is it starts with 1, goes to 2, and then 3, 4, 5, 6, 7, and then there's 3 groups, which are 8, and then it goes back to 1. So it's kind of weird because of that. There is a reason to why they do it this way. We're not really going to go into that, but either way, it's much simpler just to name the groups from 1 to 18, and that is the preferred way of naming by IUPAC. Like I stated previously, we're going to look at the families on the periodic table, and within each family, the elements have very similar physical and chemical characteristics, and we're going to discuss that in this video. So the first family that we're going to look at are the alkaline metals, and these are again the group 1 metals shown here. These metals are very, very reactive, and in fact they react vigorously with air and water. And if you wanted, there are many videos on YouTube of how sodium or any of the other metals react with air and water, and they're pretty cool. So if you want, you can go check that out. And in terms of reactivity, the reactivity increases as you go down. So francium would be the most reactive alkali metal, and in fact, it's the most reactive metal in general. Sometimes you might see cesium being mentioned as the most reactive metal, and that's only because francium is not really found in nature and it's very unstable. So usually it's made in labs, but even then it's very unstable, so it breaks down really quickly. And because of that, some sources will say cesium is the most reactive metal because it's actually found in nature, although it is quite rare as well. The alkali metals form basic solutions in water, and that is why they're called alkali metals, because alkali refers to the word alkaline, which means basic pH. In terms of their physical characteristics, they're all solid at room temperature, they're all shiny, and they're all soft. And what I mean by soft is you can easily cut them with a knife. And another thing I want to add is that although metals tend to have really high melting and boiling points, alkali metals tend to have really low melting points. An example of this is cesium, and cesium's melting point is around 25 degrees Celsius, which is quite low for metals because metals can have melting points anywhere from 1,000 to 3,000 degrees Celsius. So 28 degrees Celsius is quite low for a metal. One more thing I want to add is that hydrogen isn't really considered alkali metal because, in fact, it's not even really considered a metal because its properties are so different from the other elements in group 1. And this, again, just shows how soft the alkali metals are, and I believe this is potassium being cut, and as you can see, it's easily cut by a knife. Next, we're going to talk about the alkaline earth metals, and these are the group 2 metals shown here. They're also quite reactive, although not as reactive as the alkali metals, which were the group 1 metals. They react with air and water, but there are some exceptions. Beryllium does not react with air and water, and magnesium, although it does react with air and water, it reacts very slowly, so you have to provide heat if you want it to react faster. Other than that, the other metals near the bottom, they all do react with air and water quite nicely. And just like with the alkaline metals, the reactivity of the alkaline earth metals increases as you go down. So the most reactive alkaline earth metal would be radium. Again, alkaline earth metals form basic solutions in water, and that explains why they're called alkaline earth metals. Alkaline, again, means basic pH. And in terms of physical characteristics, they're all solid at room temperature, they're all shiny, and they are all soft, although they are harder than the alkali metals. And again, they have low melting points. Their melting points are not as low as that of the alkali metals. Their melting points are a bit higher than the alkali metals, but compared to other metals, such as some transition metals, their melting points are quite low. Now we're going to move on to the nonmetals, and the first group that we're going to talk about are the halogens. The halogens are very reactive, and the reactivity is quite comparable to that of the alkali metals, which were the group 1 metals. And since the halogens are so reactive, they react a lot with alkali and alkaline earth metals, and an example of that would be NaCl, which you'll probably know as sodium chloride or table salt. And in terms of reactivity, I mentioned that for alkali and alkaline earth metals, reactivity increases as you go down. So these two metals would be the greatest in terms of, they would have the greatest reactivity. However, for the halogens, it's the exact opposite. So reactivity increases as you go up. And that means that fluorine is the most reactive halogen. And in fact, fluorine is the most reactive nonmetal as well. In terms of physical characteristics, fluorine and chlorine are gas at room temperature and pressure, bromine is a liquid, and iodine and astatine are solids. And halogens tend to have low melting and boiling point, which is very characteristic of all nonmetals. And another thing I want to add is I didn't really mention element 117 as a halogen, and that's because it's a synthetic element, which means that it's only made in the laboratories, and also it's very unstable. So we do not really know a lot of its properties because it breaks it down so quickly. But from what we do know, it has been proposed that it most likely does not behave like the other halogens. And that's the same thing with element 118. When I talk about the next group, which are the noble gases, I won't mention element 118 because it's technically not considered a noble gas. So the next group that we're going to talk about are the noble gases, and they are personally my favorite group because they are so chill. They're very stable, so they don't react at all during at room temperature. Now, that doesn't mean that they never react, and in fact, they do react under extreme conditions. So, for example, xenon can bond with fluorine and form some stable compounds, but in order to have that bond form, you need to put xenon and fluorine through a high amount of heat. But yeah, in general, at standard temperatures and pressures, they do not react. And because of that, they are monatomic gases, which basically means that they don't bond with themselves. So for example, chlorine, you'd never find a chlorine molecule by itself. You'd always find chlorine as Cl2, and therefore it's diatomic. However, for the noble gases, they're always by themselves. So it's always going to be He, it's never going to be He2, and so on. The noble gases are colorless, they're tasteless, they're odorless, and they're non-flammable, so very, very stable. And again, they have really low melting and boiling points, just like other nonmetals, and that is also why they're all gas at room temperature. However, they are very cool because they can be used in neon lights. So basically, when you put them in a tube under low pressure and provide electricity to them, their electrons can convert the electrical energy into light energy, giving off neon light colors. And this is just a picture showing the different noble gases and what color they give off inside of the tubes. Thank you for watching. Hopefully this video was helpful to give you more insight about the alkaline metals, alkaline earth metals, the halogens, and the noble gases.